Yeah, so for this one here, I had to re-record this. So, usual story, 1 plus the derivative squared, and the derivative of log sine is sine on the bottom, and the derivative of sine, which is cos on the top, squared. And you can change the 1 into sine squared over sine squared. So what you really have is something like this, sine squared over sine squared plus cos squared over sine squared. That's a common denominator, so you can put it like that. But sine squared plus cos squared is 1. So it's just root 1 over sine squared, which is 1 over sine. Now we need a bit of a substitution here. So notice that if you have y equals log tan x, then the derivative of y would be tan x on the bottom and the derivative of tan, which is sec squared on the top. Derivative of sec, sec squared is 1 over cos squared. And tan is sine over cos. So you could multiply above and below by cos. What about if we multiply above and below by cos squared? So you get 1 on the top, and then you'd get a cosine on the bottom. If I was to put a 2 on the top and a 2 on the bottom, then I have a trig formula on the bottom, which is 2 over sine 2x. So the angle will be twice as big. So if I was to do y equals log tan x over 2 instead, how would that change the calculation? So if that was x over 2, it'd all be the same except on the top line. Oh, well, that'll be x over 2, and that'll be x over 2. And the chain rule on the top line adds in a half on the top. So there'd be a half here, and that'd be x over 2, x over 2, x over 2. That would be x over 2, x over 2. The half still there. The half still there. So they'd cancel out. And that'd be x over 2, x over 2. So that'd be over 2. So that'd be 1 over sine x. So that's equal to log tan x over 2, 3/4 pi, and pi over 4. So let me continue that over here. I should have done that on the side. So over here, that would be log tan 3 over 2 pi minus log tan pi over 8. Oh, sorry, no. Divide that by 2, that's 3 over 8. And then that's pi over 8. So that would be log bracket tan 3/8 pi over 1/8 pi. Now, does that at all simplify? Let me see. Tan 3/8 pi over tan pi over 8. Funny enough, it's nearly 3, but not exactly 3. So it's very, very roughly equal to log 3, but not quite. So in total, it's about 1.098. Yeah, about 1.098. Let me just check numerically here. Pi divided by 4, and then 3/4 pi root 1 plus that squared. Cos over sine is also the same as 1 over tan. Let me see if the calculator numerically agrees. It does not. Because I'm in degree mode. Yeah. Hang on. Right, let's see. Huh. Oh. Does the sign... Let me make the... Hang on a second. I need to make a graph here. Okay, let's see. Log sine x. Pi over 4 to 3/4 pi. Okay. There. There. All right, there is no breakdown on the graph here. But my integral on my calculator doesn't like me doing this, so I'll use the software. Okay. So square root 1 plus okay. Square root 1 plus the derivative of x squared. Integrate from pi over 4 to 3 pi over 4. Ah! Did I? Huh? What's gone wrong? Log sine pi over 4. Did I put it in backwards? Maybe I did. Lower limit. Upper limit. $1.76. That's not quite what I got. And why is it negative? What has gone wrong? 1 plus the derivative squared square root. Yeah. And the function is log sine. But it's negative. Why is it negative? What is going on here? What is going on here? That's 1 over the absolute. Yeah. Oh, does sine not stay absolute or positive between those two intervals? That's what I was saying earlier. Pi over 4. And then 3/4 pi. Now it does stay positive, so the absolute is redundant. So now if I integrate that, lower limit that, upper limit that. Okay, sorry, I did have it in backwards. Okay, 1.76. That's funny. Hmm. 3/8 pi. And then pi over 8. Maybe I just typed it in wrong. Log tan 3/8. Oh, because I had it in degree mode earlier. Isn't that what it was? Yeah. Yeah, so I'm getting, now that I'm in radio. Ah, what a classic student silly mistake. About 1.76. And is that what Derive is telling me? Yes. We did it.